Now that we have completed the little mini lesson on acid-base naming, we can use it to our advantage in this question. So it says a solution of sodium hydroxide. Well, we can look up sodium in our periodic table. It's Na, charge of +1. We should be making an ionic compound here because it's metal and then non-metal. Hydroxide is pretty simple. It's OH -1. It's in our polyatomic ions right over here, hydroxide, OH -1. And that reacts with sulfuric acid. So we can use our naming rule to help figure that out. Well, we notice that sulfuric acid, that goes with this naming rule here, considering that this naming rule ends in ic, right? You guys see that ic I highlighted purple? So let's try that out, sulfuric. So if it's sulfuric acid, that must have meant that the ion ended in 8. So that must mean that this used a sulfate ion because it turned into sulfuric acid. No hydro in front, no OUS ending, it was an ic ending, right? So 8 always turns to ic, as you guys know. So what's the sulfate ion look like? Well, let's look it up. There it is, sulfate, SO4 -2. So SO4 -2. Now, we should also know that when something is an acid, especially strong acids like sulfuric, they get that due to the fact that they have hydrogen ions on them, right? So, of course, we've got to use our sulfate ion and our hydrogen ion to make this acid. So the charge of sulfate is -2. The charge of a hydrogen ion is +1 in this case. So how many hydrogens do we need? Well, that means that we need 2 hydrogens, H2 +1, and then another +1 to balance out with the SO4 -2, right? And so there's our sulfuric acid. Okay, now let's put these together into our formula. Sodium hydroxide, we just need 1 of each. A +1 sodium with a -1 hydroxide. It's in solution, so it's aqueous. And we react that with sulfuric acid, which definitely is in solution, H2SO4. So we've made aqueous there. And when we react acids and bases together, we should kind of remember that the H's and the metal of the base kind of trade in order to make water. So when I take an H off of this H2SO4 and give it over here, it makes HOH, which is also known as H2O, liquid water. And the sodium comes over here, and it's kind of an interesting situation because, technically speaking, we could take both hydrogens off of the H2SO4. It's diprotic. But in our case, we've only taken one. So we've got sodium, Na +1, hydrogen +1, and SO4. And that will be aqueous in solution. Now our next step is, of course, to balance this out. So when balancing this equation, I think it would be good to start with maybe SO4, because it's found only in, well, let's start with the S, I guess. It's only found in one product and one reactant. So there's 1 over here, 1 over here. So that means we should be good to start at 1, 1. What about Na? We've got 1 over here, 1 over here. Looks like pretty good to start with 1, 1. So what if we start with something like this? Let's see if everything works out. What about the number of hydrogens? This is 1 times 1 hydrogen, 1 times 2 hydrogens. So that's 3 hydrogens for the reactants. 1 times 2 hydrogens there, 1 times 1 hydrogen there. That's 3 hydrogens there. So the hydrogens check out, that's good. Let's try the oxygens. 1 times 1 oxygen, 1 times 4 oxygen. That's 5 oxygens on the reactant side. 1 times 1 oxygen, 1 times 4 oxygens, that's 5 oxygens on the product side. So looking good. I think balancing this as a 1 to 1 to 1 to 1 is perfect. Okay. Thank you.